Welcome to the Deep Dive. Today we're focusing on a topic that's really not just making headlines, it's actively reshaping how whole industries operate. We're talking about the critical distinction between what we've traditionally called traditional AI and this more recent paradigm-shifting wave of generative AI. I mean, the sheer speed at which sophisticated tools like ChatGPT just exploded into the public consciousness back in late 2022. It really made a clear, nuanced understanding of this difference absolutely essential. So our mission for you today is to distill the most important insights from, a whole stack of resources. We've looked at cutting-edge academic papers, insightful educational videos, online courses, detailed industry analyses. The goal is to give you a concise, yet hopefully pretty profound overview.
That's precisely right. And I think for anyone engaging with artificial intelligence, whether you're, a seasoned practitioner or maybe just trying to keep pace with the advancements, establishing a consistent, a well-defined understanding is key. Understanding traditional AI, and you might hear other terms like good old-fashioned AI or maybe predictive AI versus generative AI. It's fundamental. This clarity, it really helps prevent conceptual ambiguities, especially with all the varied terminology floating around. So yeah, we'll be synthesizing diverse perspectives to make sure you walk away not just knowing what these differences are, but truly understanding why they matter to the broader field of AI and, of course, its practical applications.
Okay, so let's really get to the heart of it then. What's the most crucial, the fundamental difference in what these two types of AI actually do? What's the core action?
Right. From a foundational academic perspective, if we look at how generative AI has been defined in recent literature, its core capability really lies in generating seemingly novel content. And that's the key phrase, seemingly novel. It isn't just, regurgitating existing information. It's about creating something that feels genuinely new. This content, it can manifest in incredibly diverse forms, text, obviously, but also audio, video, images. And how it does this? Well, it's achieved by learning these really intricate patterns from vast quantities of existing data. Then it synthesizes entirely new content from those learning patterns. It's not merely classifying inputs or predicting outcomes, which, as you said, was always characteristic of earlier AI systems. So right off the bat, that reveals a crucial divergence: creation versus analysis or prediction.
Versus analysis.
Yeah. And what's truly fascinating here, I think, is the underlying concept of foundational models. It's a term Stanford University researchers coined back in 2021. These are typically very large AI models trained on immense quantities of unlabeled data. That's important. The data doesn't come with explicit tags or categories. And these models can then be adapted or fine-tuned for a really wide range of downstream tasks. Many of today's most powerful ones, especially in language, leverage a transformer architecture. That's a type of neural network designed specifically to understand context, relationships within sequential data like language. That architecture has proven incredibly effective, really a cornerstone now. This ability to build general knowledge from huge, often unstructured data sets and then apply it to generate diverse original outputs, that marks a significant departure from the more narrowly focused models we typically associate with traditional AI.
That distinction, creation versus classification or prediction,
yeah,
it really does crystallize it. I'm curious, though, for those of us who aren't deep AI researchers, how do educational resources simplify this core idea? Do they use analogies maybe that make it click more easily?
Oh, absolutely. The explanatory videos often use very clear analogies to bridge that conceptual gap. It helps a lot. They often frame traditional AI as primarily used to automate and simplify existing tasks, basically following predefined rules or identifying patterns learned from data. Think of real-world examples you see every day. Grammar checking software flagging errors based on learned rules, right? Or the autocomplete on your phone predicting your next word, navigation apps calculating the best route using existing map data, or even those customer service chatbots responding based on scripted answers. These systems excel at performing tasks that are essentially predictive or analytical, but within a defined scope. They make existing processes more efficient.
Okay, automating and simplifying. Makes sense.
Exactly. In stark contrast, generative AI goes significantly beyond that, beyond just mimicking intelligence. It creates entirely new content. It sort of emulates human creativity by combining and reinterpreting elements from its massive training data in novel ways. So this could involve generating unique, coherent text, synthesizing original photorealistic images, composing new music, or even producing complex video sequences from just a simple prompt. So yeah, this core differentiation automating existing tasks versus creating entirely new original content that really provides a fundamental understanding of their differing capabilities and, frankly, the transformative potential that generative AI brings.
That's a really powerful way to frame it. Okay, so building on that core function, but let's move beyond what they do for a second. What about the underlying architectural philosophies, or even the core purpose that truly differentiates these two AI paradigms?
Right, good question. From a purpose standpoint, traditional AI typically focuses on, the rigorous analysis of existing data, recognizing intricate patterns within that data, and then subsequently making informed decisions or accurate predictions. This has historically been the primary domain of data scientists, right? They architect systems to extract insights, automate responses based on these analyses. The goal is often optimization, prediction, or classification.
So extracting value from what's already there.
Pretty much. Generative AI, on the other hand, it fundamentally shifts this paradigm. It enables the creation of new content across various modalities, and it's not just text and images anymore. We're talking music, functional code, sophisticated video sequences. This pivot in purpose from analysis to, well, pure creative synthesis, that's a defining characteristic. And you could argue it democratizes AI, making powerful creative tools accessible to a much wider audience.
Okay, so the purpose shifts from analysis to creation. What about the architecture itself? How different are they under the hood?
Profoundly different, actually. Traditional AI often involves let's call it a clearly defined pipeline. You've got a repository of structured data, usually. Then an analytics platform to process that data, and an application layer designed to act on the insights derived. The process typically includes a feedback loop to continuously refine the models based on their performance, their accuracy against real-world outcomes.
A structured flow.
Exactly. Generative AI, though, embarks on a different architectural journey altogether. It typically starts by processing just massive amounts of data, often scraped directly from the internet. It's a mix of structured and, crucially, unstructured information. This data is then processed by large language models, LLMs for text, or other foundational models for images, audio, etc. These LLMs are essentially vast neural networks trained on enormous amounts of text data to understand and generate human-like language. Now, while these models are immensely powerful, they frequently require subsequent prompting and fine-tuning. You might hear terms like in-context learning or few-shot learning to adapt them for specific use cases or desired outputs. So the feedback loop in generative AI primarily focuses on this iterative prompting and tuning stage rather than direct model retraining based on, say, predictive accuracy in the same way.
Interesting. So the feedback loop is more about refining the request or the context for the generation.
In many cases, yes, especially during inference or application. And a critical architectural difference here is data type. While traditional AI often depends on clean, structured data, think spreadsheets, databases with clear labels and categories, generative AI is uniquely capable of handling both structured and unstructured data. It can even infer and fill in missing information based on the complex patterns it learned from its vast training corpus. This adaptability to diverse data types significantly expands its scope and the kinds of problems it can tackle.
That's a fantastic breakdown. So if traditional AI is like this highly specialized, finely tuned machine for a particular job meeting clean blueprints, then generative AI is more like a huge adaptable workshop that can churn out all sorts of new things, even for messy sketches. Is that fair?
That's a pretty good analogy, actually, yeah.
Okay, so given these distinct approaches to data and architecture, how do their learning methods then diverge? What are the typical paradigms they use to actually gain knowledge?
Yeah, the learning paradigms differ significantly, and this is really crucial to understanding their capabilities. Traditional AI, most often, relies on supervised learning. In this approach, the model learns from labeled data. Each input is explicitly paired with its corresponding desired output. So, for example, an image classification model learns to identify cats because it was shown millions of images explicitly labeled cat and maybe not cat. The model's objective is to accurately map these inputs to outputs, allowing it to generalize and make predictions on new, unseen data. It needs that supervision.
Right, needs the labels, the answers provided during training.
Exactly. Generative AI, conversely, frequently employs unsupervised or self-supervised learning techniques. These methods allow the models to learn complex patterns and structures from large amounts of unlabeled data without explicit human guidance. You can think of it like learning a language just by listening to millions of conversations. Without anyone explicitly telling you this is a noun or that's a verb, the AI figures out the grammar, syntax, semantics on its own, maybe by predicting missing words or the next word in a sequence. By identifying these inherent patterns, generative AI can then generate new, similar data that adheres to the learned distributions. This fundamental difference in how they acquire knowledge from explicit labels versus inferring structures from vast, raw, unstructured data, that's a key operational differentiator. It's a big reason generative AI can create truly novel stuff.
Okay, that makes sense. Now, when it comes to what they actually produce, the outputs, and also how transparent their inner workings are, we see even more critical distinctions there too, don't we?
Absolutely. The outputs are a primary differentiator, and they directly reflect those core functions we talked about. Traditional AI typically generates predictions like a numerical forecast for stocks or customer churn, or classifications identifying spam emails, a medical diagnosis based on symptoms, or automated actions directing a robot arm, adjusting a manufacturing process. These outputs are generally deterministic or probabilistic within a defined range and directly tied to the input analysis. They aim for accuracy and efficiency in predefined tasks.
Predictable, in a way.
Often, yes. Generative AI, as the name strongly suggests, produces new content. This can range from coherent, contextually relevant text to photorealistic images, compelling audio tracks, original video, even functional software code. Its output is characterized by novelty, creativity, and often a degree of surprising originality.
And what about transparency? Can we understand how they reach these outputs?
Well, that's another major difference. The level of transparency and interpretability often varies considerably. Traditional AI models are generally more transparent. Their decision-making processes are often easier to trace and understand. For instance, a decision tree model for loan approval can literally show you the exact criteria it used. This interpretability makes them more suitable for applications where explainability and accountability are paramount. Think healthcare, finance, legal systems. You need to know why. Generative AI models, particularly the very large deep learning models like LLMs, can be significantly opaquer. They're frequently referred to as black boxes. And that's because it's profoundly challenging, sometimes practically impossible, to understand exactly how they arrive at a particular output. Their immense complexity, billion or even trillions of parameters, and the emergent properties of their learning make their internal logic incredibly difficult to deconstruct. This lack of transparency can be a significant hurdle, especially in fields where accountability, fairness, and the potential for bias are critical concerns. It makes it harder to debug, ensure equitable outcomes, or even fully trust their decisions.
That black box issue is definitely a hot topic.
It is, and it also means generative AI typically requires substantial computational resources and extensive training time, often far exceeding the requirements of traditional AI. And it generally needs much larger, more diverse data sets compared to traditional AI models, which can sometimes operate effectively with smaller, more structured data sets for well-defined tasks.
That concept of the black box is critical, especially when we start thinking about accountability and trust. So if these models have such distinct internal complexities and resource demands, how do their fundamental operational cycles differ? Do they process information in inherently distinct ways?
Indeed. There's an interesting perspective from recent research that highlights their fundamental operational loops, and it really underscores these inherent differences. Traditional AI, across its various applications, spam filtering, facial recognition, you name it, operates predominantly in a closed loop. This means it uses existing, predefined information and learned patterns to solve problems or perform specific tasks, but within established boundaries. The system consumes data, processes it, produces an output that fits within a known set of possibilities. Think of, say, a predictive maintenance system in a factory. It analyzes sensor data, identifies a pattern indicating potential failure, and then outputs a prediction of when that might happen. It doesn't try to design a new machine. It works within the parameters of the existing one.
Okay, operating within known limits.
Exactly. Generative AI, in contrast, operates in an open loop. It learns deeply from its training data, then leverages that learning to create entirely new data that didn't exist before. This is obvious when it generates images from text descriptions, creating a visual that's never been seen, or crafts creative text formats from a brief prompt, producing a story with novel plot points. This distinction in their operational paradigm profoundly underscores the creative, the truly generative nature of the latter. It allows it to move beyond merely analyzing and optimizing existing realities to actively synthesizing new ones. It's kind of a shift from interpreting the world to imagining new worlds.
Wow, interpreting the world versus imagining new worlds. That's a really insightful way to put it. So what does this all mean for real-world applications then? How are industries actually leveraging these distinct capabilities? Where are they thriving?
Yeah, the industry perspectives offer incredibly valuable insights here. Traditional AI is robustly used and still essential for critical analytical tasks. Think fraud detection, identifying anomalies in financial transactions by comparing against historical patterns. Absolutely crucial. It's essential for building sophisticated recommendation systems, personalizing user experiences on e-commerce sites or streaming platforms, predicting what you might like based on past behavior. And it's paramount for accurate speech recognition, converting spoken language into text with high precision. These are fields where pattern recognition, classification, prediction based on historical data are the bedrock.
The analytical backbone, really.
Precisely. Generative AI, on the other hand, well, it powers the highly visible, dynamic tools we've seen emerge so dramatically recently. Conversational AI like ChatGPT for dynamic interaction content creation. Image generation tools like DLE. These facilitate the creation of dynamic, innovative, often highly creative content. And they're transforming industries from marketing and advertising to entertainment, product design, even scientific research, generating novel molecular structures, for example. A key technological difference highlighted by industry sources is that generative AI extensively leverages these advanced deep learning techniques, and it exhibits this remarkable ability to adapt to unstructured data. That makes it far more flexible and innovative for complex content creation tasks compared to the more rigidly structured processing often found in traditional AI.
It certainly sounds like they serve very different, though equally important purposes, specializing in distinct aspects of intelligence. But despite these fundamental differences, is there potential for these two powerful approaches to actually work together? Could they create something even more potent?
Yes, absolutely. That's a critical point. While they are distinct in their core functions, these two types of AI are not mutually exclusive. Not at all. In fact, there's significant and I'd say growing potential for them to be used in tandem, synergistically, to achieve more comprehensive and powerful solutions. Consider a practical scenario, maybe in customer service, which many of us can relate to. Imagine a large retail company wanting to enhance its customer experience. Okay, goal 1. Analyze 50,000 incoming customer reviews to identify the top 5 complaints and categorize the sentiment positive, negative, neutral for each review. For that task.
Traditional AI seems like the obvious choice.
Exactly. Traditional AI would be the most suitable approach. Its strengths lie precisely in that kind of large-scale data analysis, pattern recognition, classification. It can efficiently process that existing text to derive structured traits. Okay, now goal 2. Draft unique, empathetic, and personalized apology emails to every customer who left a negative review.
Ah, that requires creation personalization.
Precisely. For that task, generative AI would be far more suitable. It requires the creation of new, original text content, tailored to specific feedback, maintaining an empathetic tone, adhering to brand guidelines. So this example really highlights how traditional AI can analyze vast amounts of data to produce actionable insights like identifying the problems and the customer sentiment, which can then be seamlessly fed into generative AI to inform and guide the content creation process. This powerful synergy shows how analytical AI can inform creative AI, leading to more effective, personalized, and efficient outcomes than either system could likely achieve on its own.
That makes perfect sense. So to summarize this deep dive, it seems unequivocally clear that the core distinction between traditional artificial intelligence and generative artificial intelligence really lies in their primary objective. Traditional AI focuses on rigorously analyzing existing data, making precise predictions, classifications, or automating tasks based on learned patterns. Generative AI, on the other hand, is purpose-built to create new, original content, things that simply didn't exist before. And these fundamental differences, they really permeate various critical aspects, their learning paradigms, data requirements, output types, even model transparency.
Indeed. And both traditional and generative AI are invaluable tools. Each possesses unique strengths, optimal applications, and yes, inherent limitations too. As this expansive and frankly rapidly evolving field of AI continues its trajectory of innovation, a clear, nuanced understanding of these distinctions is increasingly important. For students, researchers, practitioners, really anyone involved, and if we connect this to the bigger picture, it's abundantly clear these approaches aren't always mutually exclusive. In fact, there's growing potential, maybe even a necessity, for strategically combining them to create even more powerful, versatile, maybe more contextually aware AI solutions that can address complex, multifaceted problems that might be beyond the scope of either approach alone.
And think about the profound implications of that synergy, that combination. As traditional AI gets even better at precise, large-scale analysis, pattern recognition, and generative AI gets better at novel, creative content generation. How might their combined power accelerate discovery, spur unprecedented creativity, solve complex problems in ways we're only just starting to grasp? Imagine a system analyzing massive scientific data sets, identifying correlations no human has seen, then using generative AI to propose novel hypotheses, or even design entirely new experiments. The possibilities truly feel limitless, don't they?